if the bread cools to 210 in 20 minutes, so here's what we know, that after 20 minutes, the temperature is 210 degrees. Okay? How about, do you need a microphone, or
It's picking up audio right now.
it's picking good video,
And
audio?
you see the audio response right there.
Okay, cool. So the question is, how much longer? How much longer? This is the tricky part. It's not the absolute time, but the time after 20 minutes. It will take the bread to cool to 880 degrees. So we're going to say that T equals 180 degrees. Find delta time, okay, which is time after, let's see, time minus 20 minutes. Okay? Does it make sense? So the solution, because the temperature is a function. Let's go to the basic stuff. Let's see, T prime is K T of T. Then we know that we have. No, let's skip that part. That part is really unnecessary. We know that this is an exponential function. We're going to set up the y function. We're going to set up let y equals t of t, and this is y is a function of t, minus the ambient temperature, T sub s. So it will be T minus the 70 degrees. Okay? And we need to also set up the initial values. Y sub 0 will be T sub 0 minus 70, or it will be 350 minus 70, and therefore it will be 280 degrees. Okay? And when T equals 20 minutes, then Y at 20 would be T at 20 minus 70. So we're looking at 180 minus 110, or, I'm sorry, minus 70, which is 110 degrees. So far, so good? Now, we know that y is an exponential function, so y of t equals y sub 0 e to the power of kt. That's what we know. And the trick is to find k first. So we're going to use the 20 data. So again, we'll let t equals 20, and y at 20 equals 110. So 110 equal y sub 0, which is 280, e to the power of k times 20. $180 minus 70 is 110. Not 180 yet. Okay. Oh, okay, yeah. You're right, right. We want to find when do we have 180. So yes, let's correct that. Okay, so thank you. So T of 20 is 210 minus 70 degrees. So we're looking at 140 degrees. So now we're going to say that 140 equals 280. And from here, if we divide by 280, you get 1/2 equals e to the 20k. And you apply the natural log. Well, the natural log of 1/2 is negative natural log of 2, right? natural log of 1/2, which is the same as natural log of 2 to the negative 1, which is the same of negative natural log of 2, and that's equal to the natural log of 20 e to the 20k. So this is equal to 20k, and therefore k equals negative natural log of 2 divided by 20. So we have k, and I wouldn't calculate it numerically at this point, because if you calculate it numerically, you will have a rounding error. I'll leave it like that. And we want to find when t equals 180. Well, when t equals 180, then y, t of t equals 180, then y of t equals 180 minus 70, and that would be the 110 degrees. Okay? So we want to find t at this time. So 110 equals, remember, we go back to 280 e to the kt, and this is what we need to find. We need to find t. So solve and get 11 divided by 28. Once you divide everything by 280, equals e to the kt, and apply the natural log to both sides, and the natural log of 11 divided by 28 equal kt, and the time t equal natural log of 11 over 28 divided by k. But k is the natural log, or negative natural log of 2 divided by 20, so here we need to plug some. Again, I still don't want to calculate any value. I want to stay like this. And since we're dividing by a fraction, I can write it as negative 20 times natural log of 11 over 28 divided by natural log of 2. And this one I'll calculate. Okay, so plug it in a calculator and calculate it. So I'll do it on mine, you do it on yours, and see who wins. If you pay attention to the parentheses and all this good stuff, then you say you have 20 times the natural log. You want to see what I'm doing? Say yes.
Yes.
Thank you. Okay, and I have the negative sign up front, which I forgot, so let me insert the negative sign, like so. So I have negative 20 natural log of 11 over 28, and now I'll divide everything by the natural, not here. But at the very end. Now I'll divide by the natural log of 2. And if I got it right, it should be positive, and it's positive 26.96. Okay? So I'll round it as about 27 minutes. Okay? So we are looking at delta t. Delta t will be 27 minus 20, so the answer will be 7 minutes.
If you switch it back,
That's tough, what you're asking me to do. Okay, so let's write. Okay. So the calculation, the result of the calculation is about 7 minutes. But this is t, and we need to find delta t, and therefore this is the answer. So, I'm sorry?
When you solve above, you were meant to do 27 above the delta t. It's not a big deal.
Above that.
Oh, I'm sorry, I wrote 27, but it's 27. I just forgot to put the 2. Okay. All right, so this is problem number 1. Problem number 2, the relative rate of change. Okay, so this relative rate of change, ROC, is defined by f prime divided by f, or y prime divided by y. Okay. Remember, we saw that this is when you're talking about exponential law, this is equal to a constant. Remember, that will be the relative growth rate, RGR, relative decay rate, RDR. Another name for it is relative rate of change. Okay, so if it's growth, we're going to call it RGR. If it's decay, we're going to call it RDR. But it's the ratio. Okay, so we want to find relative rate of change of y equal square root of t as a function of t. Okay, so let's just, this is a side note. Recall that if y prime over y equals k, then y equal y sub 0 e to the power of kt. That's the theorem of exponential growth and decay. Okay, if we have relative growth or relative decay. All right, but that's a side note. So in our case, y, in this case, we have the following. Y equal the square root of t, and y prime equals what? Equals the derivative of square root of t is 1 over 2 square root of t. Okay? And the relative rate of change equals y prime over y, so it will be 1 over 2 square root of t divided by y, which is square root of t. Okay? So now is the basic algebra here. It will be 1, and we have 2 square root of t times square root of t, like so, and eventually we get 1 over 2t. So this was not really a relative rate of change. This is 1 and 2 are still belongs to, for some reason, what is the section? 4.8 when we had exponential growth and decay? It belongs to this section, deal with exponential growth and decay. Let's put it this way. So it migrated into this packet. The volume of a sphere, okay, that's a true relative rate of change. So we have the volume of a sphere. So the volume of a sphere and I believe I did this problem in class, or similar like this, similar to it. V as a function of r, the volume of a sphere is 4 over 3 pi r cubed. Okay? And now we know that what is given, by the way, Robin, do you have this packet?
Yes.
Oh, okay. So everybody here has a packet because I have 2 or 3 extra on the desk over there, if you don't have it. Okay, so what's given to us is that the volume of the sphere, dV dt, is increasing at the rate of 5 cubic centimeter per second. So we have that dV dt is positive, the volume is increasing at the rate of 5 cubic centimeter per second. Okay? This is given. And what else? Find the rate of change of the surface area when the volume is 32 pi over 3. I did it before the test too. Okay? So what we need to do is find, okay, I'll tell you what, before I go here, I'll say S surface area. I'll denote it as SA. If you don't know it, the surface area is the derivative of the volume. We talked about that, and I told you this is one of the things that got me hooked on calculus. The idea that the derivative of the volume is the surface area blew my mind when I saw it for the first time. And the same thing, we talked about the idea that the perimeter, the circumference of a circle is the derivative of the area of a circle. That's another of this mystery of the universe, how it was designed such that the designer used calculus. Of course, we are trying to figure out nature. Nature is not trying to figure out what we do, but it's still amazing that the relationship between calculus and nature, or the law of nature. Anyway, what we want to do, we want to find the rate of change of the surface area. So we want to find d dt of SA, the surface area, when the, let's see, what is given when the volume is 32 pi over 3 cubic centimeter. All right, so now we have the data, and we try to make the connection. Well, first of all, let's find the VDT, and let's find the SADT, and see if we can get some help here. All right, so this is V of R. Okay, V of T by the chain rule will be V of R of T, or the composition V composition R of T. And therefore, dV dt by the chain rule will be dV dr times dr dt. So far, so good? Okay, so we really can't get the SA dt, but we can get the R dt, which is as good as finding the SA dt. So dV dr, we said it's 4 pi r squared, right? If you take the derivative here, and then you have the R dt. Now, as it happened, we know this value. We know that dV dt is 5, right? So this equals to 5. And this equals SA, the surface area. So let's see what if this helps us. Well, it does not, but if we can figure out R squared, and we can figure out R squared from this information, then we are good to go. Let's see, what do we need for in this dSA dt, the rate of change of the surface area? Well, dSA dt is ddt of 4 pi r squared. Okay, so again, we'll do the chain rule, and we have 8 pi r times dr dt. So here's the strategy. If I can get a value for the r dt from this expression, plug it here, and have a value for r, then I can find the rate of change, dSA dt, which I'm after. You see what I'm getting at? I mean, first I'm going to extract, so let's call this equation 1, and let's call this equation 2. Going back to equation 1, and I have 4 pi r squared dr dt equals 5. From here we get that dr dt equals 5 divided by 4 pi r squared, right? So what's left to find out is figure out what is 4 pi r squared. So how are we going to do it? Well, we're going to use this value. We know that v equals 4/3 pi r cubed equal at a certain time 32 pi over 3. So from here we get the following relation. The pi and the 3 and the 3 go out, and we end up having 4r cubed equals 32, or r cubed equals 32 divided by 4, which is 8, and therefore r equals 2, and this would be in centimeter, and we are very good because we have a value of r. Now I can go back to what we want. We want d dt of SA, and we came up with this value, 8 pi r dr dt. Okay, I have a value for r, and I have the r dt, so it will be 8 pi r divided by times 5 divided by 4 pi r squared. So before I plug in values, the r dt is this one, so I have 8 pi r times 5 divided by 4 pi r squared from here. And I can do a lot of things, but at the end, if you look carefully, pi and pi, 8 and 4, so we have 2 times 5, which is 10, and it will be 10 over r. And 10 and r equals 2, so we have 10 over 2, and the solution is 5, I believe. Is that the right solution? And what is the, this is surface area, so it has to be centimeter squared divided by by second. Okay, the last thing I wrote it in unorganized manner, so let me rewrite it. I think this is an excellent test question. Don't you think?
Yes.
Okay. So this was problem number 3. 3? Yes. The next one is 6. It doesn't go silent after a while, your computer?
Do you still see yourself?
No, it's dead. It's gone. I think you have a time. Water is falling on a surface, wetting a circular area that is expanding at the rate of 9 square millimeter per second. How fast is the radius of the wetted area expanding when the radius is 165 millimeter? Round to 4 decimal. I'm not sure what was the difficulty here, but it goes like this. You have a circle that is expanding. Okay, so if you imagine a circle like so, and the circle is expanding at a certain rate, so you have something like this, right? and we know that the area of the circle is pi r squared. Okay, and what we know that dA, the rate of expansion, dA dt, is 9 square millimeters per second. Okay, this is given. So the question is, what is the rate of change of the radius when the radius itself is 165? So what we need to find is a dr dt when r equals 165 millimeter. So the solution, if a equals pi r squared, and a as a function of time is a composition, and the composition is only to justify the chain rule, because the chain rule is the derivative of composition. So we can write it as a of r of t, or a composition r of t, and therefore dA dt by the composition theorem, it's dA dr times dr dt. And dA dr is the derivative of the area is the circumference 2 pi r, and we have dr dt. And if we know dA in this equation, we know dA dt. Well, dA dt is 9, and 2 pi, we know r is 165, and we need to find the r dt. Okay, so from here you get the r dt equals 9 divided by 2 times pi times 165. Okay, so twice times 165, I believe, is 330. So we have 9 divided by 330 pi, right? You can reduce it to 3 over 110 pi. Is this the answer in the back?
Well, it's 0.7.
I don't like decimals, so I'll keep it like that. All you can do is check if 3 divided by 110 pi as the decimal equivalent of what in the back. Is it?
Yeah.
Every now and then I get lucky and I get the right answer. Don't guarantee you that it will always be the case. All right, the last one require a little bit of trigonometry. We have a wheel with a radius of 3 meters, and it rolls at 11 radian per second. So radian per second, you immediately think about angular velocity. And at how fast is the point on the rim of the wheel rising when the point is pi with 3 radian above the horizontal? So we need to pay attention to a couple of things. First of all, the relationship between linear velocity and angular velocity. And the second, the word rising. Rising means we're looking at the rate of change of velocity in the vertical position. So let's draw a picture here and see what's going on. So you have a wheel, right, that is rotating, and let's rotate it in the positive direction. It's rotated at an omega. And omega is the angular velocity is d theta dt, the change of the angle in time. So this is the angular velocity. So what happened to a point right here? If the wheel is rotating like this, then this point has a linear velocity right here. It's called v of t. Okay, the linear velocity v of t is r omega. Okay, so this will be the linear velocity. Okay. So, a couple of things that we know. We know that theta equals, at a certain point, theta of t. Let me write it differently, okay? Because the question, what happened at this time? Okay, just so remember the relations also, S, which is the displacement, is r theta. Okay, so this is the displacement or the position. And you can see that the velocity v equal the s dt, so it's equal r d theta dt, or r omega. You can see where all these three coming from. Does it make sense? So this is a little bit of background. All right, so here's r, and we're talking about the situation where the angle above the horizontal axis is theta. So right here we have theta, and theta equals pi over 3, which is the same as 60 degrees. All right? So what do we need to do? We need to find not v of t, but the vertical component. Remember, the question is how fast the point is rising. So you have this component and you have this component. And this is the vector equivalent. So v of t has the vertical component, we call it the v sub y, and has the horizontal component, we call it the v sub x. The velocity upward and the velocity forward. So we want to find v sub y, the vertical velocity, or how fast the point is rising. And v sub y, we want to find it when theta equals pi over 3. So now we analyze the problem and we are ready to solve. The solution by itself is relatively simple. Most of the work was done right here. V of t equal r omega. So V of t equal r omega, and r equal 3, so let's write r equal 3 meters, and omega equal 11 radian per second, right? This is all the data that is given. So it will be 3 times 11, and it will be meters times radian per second, so it will be 33 meters per second. Okay? Now, this is this component. The question is, what is V sub y? Well, if you look at, I'll magnify, this is V of t, this is V sub y, the vertical component, and this is V sub x, the horizontal component. The angle theta is right here. How do we know that? There is a theorem in geometry that tells you that two angles where the corresponding sides are perpendicular to each other, these two angles are equal. So look at this side. This side is perpendicular to this side, and this side is perpendicular to V, because the tangent is always perpendicular to the radius. So the angle theta sits right here. And therefore, if you complete and do the parallelogram, V is the adjacent, V of t is the hypotenuse, so cosine theta equals V sub y divided by V of t, and therefore V of t equals, V sub y, my bad, equal V of t cosine theta. And now the numbers. V of t is 33. Cosine of pi over 3, well, cosine of pi over 3 is the same as sine of pi over 6. Cosine of 60 is the same as sine of 30. It's 1/2. So we are looking at 33 times 1/2, or 33 over 2 meter per second. Is it still recording when your screen
Yes.
go good night?
Yes.
Okay. Is this the answer in the back? Yes? Man, lucky twice. I think I have a pinched nerve. That's what the problem is. It's not a muscle. I was looking at the wrong place. Can I take it off? I mean, I'm talking about the paper, not anything else. Just in case you've got an idea or something.
I'm gonna try to turn off the screensaver.
So we are looking at number 10 now. Oh no, I don't want to do number 10. As the zoom lens in the camera moves in and out, the size of the rectangular image changes. Assume, how much of this we have of related rate? I'm getting, let's switch to something else. Okay, 10. That is the last one you asked for related rate. So we have a zoom that has a rectangular image, and it's zoom in and out, okay? I'm sorry? Assume that the current image is 4 by 2 centimeter. Find the rate at which the area of the image is changing. In other words, you want the ADT. It says the ADF. If the image is changing at 0.6 centimeter per second, and the width is changing at 0.3 centimeter per second. There is a typo. It's not the ADF, but the ADT. Okay? So here it is. We are looking at a rectangular. The image is a rectangular. So we have the, let's say this is the width and this is the length. Okay? And of course, the area equals W and L. And what happened is either we zoom out, we zoom in or zoom out, and we change. So what happened is if we increase the image, then W and L are increasing. If we zoom out, it's decreasing. Okay, so now what else we know? We know that the length, the LDT, is changing at a rate of 0.6 centimeter per second. And we know that the, what else? The width is changing at 0.3. So dW dt is 0.3 centimeter per second. And we want to find the change in the area. So we want to find the A dt when we have 4 by 2, when L equals 4 centimeters and W equals 2 centimeters. So again, this is really easy solution once you figure out what's going on, because A equals W times L, okay? And W is a function of T and L is a function of T. So dA dt, now here you need to be careful because you have a product, okay? So you need to use the product rule. So it will be dW dt times L plus W times dL dt. Okay? Now, we have everything we need because dW dt is 0.3 and L is 4 plus W, which is 2, times the L dt, which is 0.6. And there you have it. So you have 1.2 plus 1.2, so 2.4 centimeters squared per second. Is this the answer?
Yes.
Lucky again.
There is a good shooter on the table. All right. Now we move on to 3.10, linearization and differentials. So we want linear approximation near 0. So f of x, what's given to us is f of x equals 1 over the square root of 5 plus x,
Is there a typo in the answer key on this one?
8 possibly. Okay, and we want to find linearization or linear approximation near. They use x near 0, near a equals 0. Okay, so what is the general form of linearization? We're going to say that f of x will be approximated by L of x, which is f of a plus f prime of a times x minus a. Okay, in this case, a equals 0. So f of 0 equals 1 over square root of 5. Okay, f prime of x, well, here we need to do a little bit of work. Okay, before we go to f prime, let's rewrite f of x in using power function notation. So instead of the radical 5 plus x, I'll write it as 5 plus x to the power of negative 1/2. So f prime will be negative 1/2 times 5 plus x to the power of negative 3/2. Okay? And the derivative of 5 plus x is 1. So times 1. And this can be written, well, I can massage it, but I can stop right here and plug 5 prime of 0. And this will be negative 1/2. 5 plus 0 is simply 5 to the power of negative 3 over 2. So it will be negative, and we have 1 over 2, and here we have 5. We have the square root of 5 raised to the power of 3, or we can write it the square root of 5 cubed, which is 125. So we can write it as negative 1 over 2 square root of 125. Okay? And now we're going to say that L of x will be square root of 5 minus 1 over 2 square root of 125 times x minus 0. So now it depends if you want to do common denominator or not, because you multiply. This is, I shouldn't do. I should have simplified the derivative. Okay, so let me take a step back and do that. Okay. Because 125 is 25 times 5. So we're talking about the square root, so we need to simplify this thing. We cannot leave it like that. So let's write so this will equal to negative 1, and we have 20 square root of 25, which is 5, so it will be 10 square root of 5, like so. This is better. Okay? Again, 125, 25 times 5, square root of 25 is 5, 5 times 2 is 10. Okay? And now we're going to write L of x equals 1 over f of 0, which is 1 over square root of 5, minus 1 over 10 square root of 5 times x. X minus 0. Okay, if you want, you can put x minus 0. And to set up a common denominator, if the common denominator is 10 over square root of 5, then you have 10 here, 10 minus 1 is, I can do it. This is multiplied by x. So you can write only 10 minus x. That will be good enough. Is this the answer in the back?
I think so. I was confused.
I mean, there you can write it, you can leave it like this. If you leave it as 1 over square root of 5 minus x over 10 square root of 5, that's fine too.
Number 18.
Yes. Either way is good. Now, if the answer is different, it may be a mistake in the packet.
I think so, because it's not even the square root of it.
It's -2 minus 1/2.
No, that's an error.
Yeah, there's
That's not correct. I remember that. I need to mentally change the answer over there.
Yeah, and I think there's an error in 26 too.
Yeah, it's quite possible. Okay, so in case you didn't see it, let me write it here. This will be 1 over 2.
So in session, you want us to leave it or we can't leave it? Like,
Either way, I'm good. I mean, this is correct. I'll take that or I'll take this. I won't be picky. I mean, both are correct. It's not like you made something wrong, like you put decimal where you ask for exact solution.
so is that created factor format? That should?
This is a correct, this is exact value. It has the radical, there is no approximation, there is no truncation. I mean, this is the exact value. If you put it in the decimal form, square root of 5, then you're introducing a little error, but just by changing into decimal form. Okay, so yeah, if you put it in decimal form, that will be, you want to get full credit. Because I'm going to tell you, give me exact solution.
I have a question for like the test. Is there anything that says round to the nearest decimal or? 'Cause on the board
I don't
we have-
remember. I don't remember. But if it says, then it will be, I mean, just round, follow the instructions. I usually prefer exact. Yeah. But if I accept, if you are supposed to give decimal approximation, you'll be instructed to how many decimal places. 23, and then we have a run on 25. So let's look at 23.
I turned the screensaver off, but it's still.
Okay, another linearization. Okay, here we need to find approximation error. Okay? So for 23, the function f of x equal square root of x. Okay? X sub 0 or a equals 5 and dx equals 0.07, and we want to find the approximation error. The approximation error, they are kind enough to tell us this is the difference between delta f and df. So we are talking about differentials. So we say that the error E, so error equals the absolute value of delta f and df. Okay, the solution, let's do the hard one first. What is delta f? Well, delta f will be the difference between f of 5.0007, I'm sorry, and f of 5. So it will be the square root of 5.07 minus the square root of 5. This requires a calculator and round your answer if appropriate. They don't tell us how to round it. So let's go with 6 decimal digits. Okay, so square root, I'll let you do that. Give me that answer. I can do it actually. Let's not be lazy here. Square root of 5.07 Okay, this is what I have. I have 0.15598. 0.015598. All right, that was the hard one. The easier one is the differential. df is f prime times dx. F prime of x times dx, right? And df, when x equals 5, is f prime at 5 times dx. F prime of x, of course, well, we know what f prime of x is 1 over 2 square root of x, so we don't need to write it again. So 1 over 2 square root of x times dx, and this is when x equals 5 and the dx equals, let's write dx equals 0.07. So we end up having 0.07 divided by 2 square root of 5. Okay, so now when we need to calculate that to 6 decimal, and I have 0.015652. So the error and it's equal to whatever it is equal to. Okay. Okay, cool. 25 is an interesting problem. This is the quadratic approximation. This is second order approximation. You guys know the first order approximation, which is the linear approximation, where we, instead of calculating the function, we're calculating the line that is tangent at a certain point. But instead of coming up with the line at the point, we can come up with the parabola at the point. And that will produce a parabola is the graph of a quadratic equation, or a second order polynomial. And therefore we say that the quadratic approximation is the second order approximation. And of course we can do third order and fourth order. In Calc 2 we look at Taylor series, which would be nth order approximation. And we can choose how far we go with that. Because at times, the first order of the linear approximation is not proper, it's not appropriate or not accurate enough. So here we go. Instead, this will be the quadratic or second order quadratic approximation.
Did we have homework on that?
I believe so. Of f of x, okay, or second order approximation. Okay, so first order is the linear, and where we say that L of f of x will be approximated by L of a plus f prime of a times x minus a. This is near x equal a. Okay, let's not forget that. And now this will be the first order. Second order or quadratic, we're going to say that f of x is approximated by Q. You know, I rush stuff here, so let me change it a little bit. I missed something here, and I'm about to miss it here as well. Okay? F of x will be approximated by L of x, which equals to f of a. Come on here. I'm getting tired. Can you tell? No? Okay, let me do this. So this will be linear approximation. And we're going to say that f of x is approximated by L of x, and L of x is f of a plus f prime at a times x minus a. Now, quadratic approximation is what you have in the problem. We're going to say that f of x is approximated by, instead of L, Q for quadratic. And Q is looks like this. I'm using this notation. It's b sub 0 plus b1 x minus a plus b2 x minus a squared. When you take Calc 2, when we'll talk about series, you'll see this will be the power series expansion of a function f of x. This form. Okay? And we stop at quadratic at 2, but you can imagine, but you can go with b3 x minus a cubed, b4 x minus 4 x minus a to the fourth, and so on. And we have a power, what we call power series, and we expand the function as power series. And this is a powerful technique to approximate functions. All right? So here's what the data. So this was a long introduction, and this is what we are told, that this happened when Q of A equal f of A. Okay, the same as we had in our function. We said L of A equal f of A, but so this is the function value. Also, the derivative, the first derivative value equal, so Q prime equal f prime at this particular point. And the second derivative also, Q double prime at A equal F double prime at A. Okay, let me write it here. So the condition for this to work is the function has to equal to the quadratic at the point A. The first derivative have to equal each other, and the second derivative. And if we had the cubic approximation, then we're going to ask for the third derivative. If we go for the fourth order approximation, we need fourth derivative, and so on. But this in Calc 2. So this is a glimpse of what we do in higher order approximation. Jesus. Okay.
So it's the second derivative of Q equals the second derivative.
This is second. We put 3. Okay. So now, the other thing we have is also f of x equal 1 over 2 plus x, and x and a equals 0. All right. So the solution goes like this. Let's start with condition 1. Okay. Q of 0 Q of 0 is supposed to equal to f of 0. Well, Q of 0, if you look at the Q right here, this is Q. So it will be equal on the left, we have a B sub 0, and then we have let's first write Q of x. Q of x, when a equals 0, Q of x equals b sub 0 plus b1x plus b2x squared, because a equals 0. And now, when x equals 0, you have b sub 0 plus b1 times 0 plus b2 times 0. So we have simply b sub 0 on the left side, and f of 0 will be 1/2. So you have a value for b sub 0. Okay? And now, move on to the next page. Let's look at condition number 2, the derivative. Well, let's look at q prime. Q prime of x equals the derivative of b sub 0 is 0. The derivative of b1x is b1. And what we have last is 2 plus 2b2x. So q prime of 0 equal b1, that's it. Because 2b2 0 times 0 is 0. What about f? Okay, if f equal 1 over 2x, I can write it as 2 plus x raised to the power of negative 1. So f prime is negative 2 plus x to the negative 2. Right? And f prime of 0 equals negative 2 plus 0 to the negative 2. And that will be negative 2 to the negative 2, or simply negative 1 over 2 squared, or negative 1/4. So we have b1 because q prime at 0 equal f prime at 0, then b1 equals negative 1/4. So now we have b sub 0 is 1/2, and b sub 1 is negative 1/4. And to find b2, we need to go to the third condition. In the third condition, we need the second derivative. So let's find the second derivative. The second derivative of q prime, q double prime, the derivative of b sub 1 is 0, and simply we'll have 2b2. What about f double prime? F double prime, if f prime equals negative 2 plus x to the negative 2, f double prime will be positive 2, negative times negative 2, times 2 plus x to the negative 3. Okay? And now we want q double prime of 0 to equal f double prime at 0. So 2b2 equals 2 times 2 to the negative 3, or 2 divided by 8, or 1/4. Okay? So b2 equals 1/8. And we have what we are after. We have b1, b sub 0. We have b1. Where are you?
Where did the 1/8
Because it's 2b2. 2b2 equals 2 times 2 to the negative 3, which is 2 divided by 8, which is 1/4. But we have 2b2 on the left side, so we divide by 2, it becomes 1/8. So here are the values. So q of x, remember it was right here, this is where we started with. So it will be b sub 0, it will be 1/2. B1 is negative 1/4 x, and B2 is 1/8 x squared. The other question is, do I think that the equation, the quadratic approximation, be more accurate or less accurate than the linear? It will be more accurate because we are equating the change of rate of the change of rate. So let's see what's the official answer here for 26. Was it 26 or 25? It says, I expect the quadratic approximation to be more accurate than the linearization. The linearization accounts for how the value of f of x is changing at the point x equal a. But the quadratic approximation also accounts for the change in this change. So that's what I said. We account for the rate of change of the rate of change by incorporating the second derivative. So the more we increase the order of approximation, the better the approximation. So third order approximation, cubic approximation will be better than quadratic. A quartic approximation will be better than cubic, and so on. Okay, you want me to do 26 now? It says, what?
Just to clarify, in the answer key, we never got the same answer.
Yeah. Raquel will.
For 26?
Yeah.
We
Let's
can
try
figure
that.
out why it's no maximum. We could always come up with a maximum.
X cubed minus 12x plus 4. This will be a short question, so it's no big deal. And this is on,
I think there's an error on the answer key for this question.
yeah, somebody already mentioned that. Okay, so we want to find maximum minimum value. So we want critical point, points, CP, and max and mean values. The solution goes like this. First, let's find the critical point. So critical numbers. F prime of x equals 3x squared minus 12, and we want it to equal 0. It won't be undefined because it's defined. There is no division by 0. So from here you get x squared equals 4. I'm sorry? And x equals plus or minus 2. Okay? So we have two critical numbers, 2 and negative 2. Okay? Since we are very smart and we know the second derivative test, let's apply the second derivative test. So f double prime of x equals 6x minus 0. Okay? So second derivative test. Okay, for x equals negative 2, f double prime of x equals negative 6. So we have local or relative maximum at negative 2. For x equals positive 2, f double prime of x equals, I'm sorry, this is negative 12. Negative 6 times negative 2 equals positive 12. So we have local minimum at x equals negative 2 here, and at x equals positive 2 here. Okay? Now, for absolute maximum minimum, we need to count also the endpoints. Okay? So we have critical numbers, and now we need to look at the endpoints. Notice that the question, if you read carefully, it doesn't say local, does it? No, it says maximum minimum value on the given interval. Ah, but the interval is open, so forget about it. Sorry, the interval is open, so no endpoints. And that's it. That's the answer. So what is the value? The value is f of x. So maximum, let's start with maximum.
The interval's not open.
It's open,
It's from -3 to 5.
But it's a parentheses.
but it's parentheses, not bracket.
So 3 and 5 are included, or negative 3.
Maximum, okay, we have f of -2, and f of -2 is -2 cubed minus 12 times -2 plus 4, or you put the calculator. So this will be -8, positive 24. So it will be positive 16 plus 4, 20. And minimum, f of 2 will be 2 cubed minus 12 times 2 plus 4. So we're looking at 8 plus 4, 12 minus 24, so it will be -12. And those are the answer. Are those the answer in the back?
The back says that there is no maximum. That's why we were all confused.
There is no maximum.
I think it's a
This is it's correct and incorrect. As far as we are concerned, it's incorrect. The reason it's some people will accept that as a correct because it's an open interval.
Okay.
And in some textbooks, if it's an open interval, you don't have a low global maximum.
So you only have a global maximum and closed intervals.
Let me graph this function, okay?
Because it does have a global max.
It does have a local max.
Oh, that's on our graphs.
This will be definitely, remember, this test give you local. So perhaps they're right. You need to look at, if you look at the endpoint, and the endpoint will be value greater than 20, then there is only local. But remember, they ask for absolute.
But if there's only one max, how is that not?
If it's only one max, it's not going to be
It's not both.
a global maximum. No. Let me show you. Okay? Let me graph the function. So it's possibly it's right. So let's see, we have x cubed minus 12x plus 4, right? And I'm not going to, okay, actually, let me go ahead and put, we go from -3 to, I'm sorry?
-3 to 5.
Okay. All right. Now, you see why we don't have a global maximum at -2? It's an only local maximum. Okay. Remember, the question has find maximum minimum without the word global or without the word local. Those, what we did with the second derivative test and critical numbers, it's the relative, not the global. The global, you need to include everything else. So if you look at this point right here, it has higher y value than this one. On the other hand, this is the lowest point in the interval. So this function will have a relative maximum, but no absolute
So
maximum.
its max would be, but why isn't it 5? Because 5 isn't included. Because it's an open interval.
It's open. That's why.
We just saw a hump. We just saw a hump of this.
Mhm. This is a very good example. Okay?
Is that a test question?
If we got something like that on the test, would you want the no maximum, or would you want us to go
Okay.
straight for-
This is local, local, local. Now, for absolute, Okay, we have no absolute maximum
Absolute means global, right?
Yes.
and our absolute minimum will be f of 2 equals negative 12. You need to be careful. If the question does not say local or relative, it means absolute, and you need to verify that your minimum maximum are indeed absolute. Okay? So this actually was a very good question.
So if that had been the highest y value on the entire interval, would it then be the absolute?
Yes. Do I still need to do 27, 28? No?
Wait, what number?
27, 28. No? Skip. 31. Okay, 31. This. Sketch a possible graph f that passes through the point P. So what we want to do, I'm thinking, so we have a parabola. I hope there is no mistake in this question. I know in the past I had some problem with this question because there was an error, but okay. So we have the x and y, and the function, this is the point P, and this is what? This is f prime. So y equal f prime of x. And here we have the same point, P, and we have about 45 degrees, but it doesn't matter. This is y equal f double prime. So what do we learn from that? First of all, let's verify. F double prime is positive from 0 to the right. So it means that the function has to increase. But f double prime is the derivative of the derivative. So if the derivative is positive, then the function is increasing. So we see agreement, and the other part is it's negative to the left. So indeed, the function that generates this derivative is decreasing. So that's okay. So what can we tell about the function? Okay, it passes through P. So the solution, we are looking at okay, let's look at the first derivative first. The first derivative equal 0 right here and right here, right? So we know that we have some kind of either maximum or minimum. The second derivative is negative to the left, so we know that we have maximum on the left. The second derivative is positive on the right, so we know that we'll have a minimum on the right. Does it make sense? Also, the second derivative is 0 at 0, so we know that we have an inflection point at 0, or change of concavity. So we have maximum right here at this value. We have minimum at this value, and I didn't line up the graphs, shucks. So I'm going through a lot of whiteout when I do these sort of things. Okay, let's line up. This is still P. So This is where the derivative equals 0. So we're going to say that we have maximum right here, right? And the function, the derivative is, the second derivative is negative, so the function is concave down. So we go like this. Now, also, look at this, the derivative. The derivative is negative in this area, so the function is decreasing. On the other hand, the derivative is positive here, so the function is increasing. So it's consistent with local maximum right here. All right, we have inflection point here, and we still decreasing because the derivative is still negative. So it's still decreasing up to right here, where we're supposed to have a local minimum right there. Ignore this square. Okay, and then the second derivative is positive from here, from 0 and on. So this is what we expect y equal f of x to be. And it passes through the point P. Okay? So, in this region, right here, f double prime is negative. In this region, f double prime is positive. Okay? In this region right here, f prime is negative. In this region right here, f prime is positive. In this region right here, f prime is positive, as you can see. This is an excellent test question. I think you have a 99.6% chance of having a question like this in the test.
All of them are excellent test questions.
No, this has 99.6. The other one has 78.9.
We just keep back on the same. You did it.
Let's use the quotient rule. We first want to find critical numbers. Okay, so we have, this is the result. we have 1, 2. So we have 1 minus x squared. We find the critical numbers, and now we need to decide what is max, what is min. We can go with the second derivative test or the first derivative test. By the way, why I'm not looking at when the derivative does not exist? Because it exists for all the numbers, because the denominator is x squared plus 1 squared. So there's no way that the denominator will go to 0. Okay, so now we'll do second derivative test. And we take the derivative here. So the G double prime. Again, quotient rule. So it will be negative 2x times x squared plus 1 squared minus 1 minus x squared times the derivative of the denominator. Well, the derivative of the denominator is 2 times x squared plus 1 times the derivative of x squared plus 1, which is 2x. All of it is divided by x squared plus 1 squared squared, so it will be x squared plus 1 to the 4th. Okay? So if you look at what we have in common here, we have x squared plus 1 squared and x squared plus 1. Also we have 2x and 2x. So we can factor out 2x times x squared plus 1. Okay, and what we have left from this one, we have negative x squared plus 1. So we have negative x squared minus 1 from here. Okay, after factoring. You see that? I hope that you see. What happened here is we have the 2x and the x squared plus 1 are factored out. So we have negative 2 plus 2x squared. And all of it is divided by x squared plus 1 to the 4th. Close the bracket. Okay? So we have x squared minus 3. So we end up having 2x times x squared plus 1 times x squared minus 3. We don't need to do it. We need to do it only if they ask us for inflection points. Because then we need to know when the second derivative equals 0. All we need to know is when the second derivative is positive and when the second derivative is negative. So I did more than required. I think there was a question of how I obtained this result. I'm gonna look at the solution and see if you can follow the steps here.
But really, all you have to do is find the critical numbers and plug them into the original function, right? To find the
Yeah, but
lower
you need to decide which one is maximum, which one is minimum.
When you plug it into the original function, you get like a positive number and a negative number. And the
True,
negative number
true.
will be a minimum.
True, but it may be something. What happens if the second derivative is 0 for this value?
Then I would.
Then
do the
it's
second.
neither max nor min. So you want to do that, or you do the first derivative test. take a value to the left, see if it's positive, take a value to the right, see if it's negative. Okay? Of course, the other thing is you can graph it, see what's happening, but in the test situation, you need to justify why something is maximum and why something is minimum. Otherwise, I won't give you full credit. So you can go either with the first derivative test or the second derivative test. But a justification is required. And telling me, hey, I graphed it and I see what's on the graph, won't cut it.
For the points, like the points won't justify it? Like, I got
No,
X is 1 and Y is.
no, I just, I'm going to want to see the test. All right? I mean, you're very practical, and I agree. So let's see, and if I was an engineer, I just go with the practical route. But we need to do the formal thing. So let's check what happened when x equals -1. Then g double prime of -1 will be positive or negative. Okay? Positive, positive, and negative. So g double prime is negative. So we have local max at x equals -1. And for x equals +1, g double prime of 1, okay, positive, wait a second, the other way around. For -1, this will be negative, positive, negative. Switch it. My bad. So it's positive here. So it's local minimum. When x equals 1, positive, positive, negative. So it's negative. So we have local maximum at x equals 1. And now you can verify it if you want by graphing it. Now, are we done here? Not really. We need to come up with the values. Okay, so unfortunately I ran out of room, so I need to go to the next page, but the maximum itself, so local max or local minimum is f of -1, so we have -1 divided by 2. Plug it in the original function and you get -1/2. And local maximum is f of 1 equals 1 divided by 1 squared plus 1. It would be +1/2. Okay? And you wanted to jump right here, but I won't let you. Shame on me. Tough. Huh?
Can I use a table to justify?
No. I need test. So either first derivative, go to the left of -1, go to the right of -1, or do the second derivative. Okay. 30, I'm sorry? 36.
Check the laptop.
Absolute extreme values. So 36. The thing is, nothing is moving here. This says will and doesn't move. This says will and doesn't move. So
They glued it down. This is the same thing.
Brittany, what is this discussion? Can I help?
No, he was just asking me like what I did, or whatever, for the problem, and I was happy to know that I had to do the test on the test to get full credit. So I'm glad we had this talk. I would have definitely just plugged in the numbers and then put this is the max and this is the min and then would have got the credit.
Okay, so we want to absolute extremum on the interval. Notice that we have a closed interval. And when we normally, remember, if it's open interval, we don't include the endpoints. If it's closed interval, we want to find use the endpoints. And here, the question is nice, and they don't omit the word absolute, but if the question find the extreme value, it's still going to be the absolute. Okay? Only when we use the word relative or local, we know that we don't need to look after the absolute value. So we need to go, do we need to classify? Let's assume that we need to classify. I'm not sure if this is the case. F prime first. F prime of x is e to the x minus 1. So we have critical numbers to look for. E to the x minus 1 equals 0. From here we get e to the x equals 1. And what does it mean? Well, apply the natural log to both sides, and it means that x equals 0. Okay?
You need to classify when you say we must classify.
If we need to classify, it means that classify the point is the extremum is maximum and minimum or minimum.
Oh, okay.
Okay, so these are critical numbers, and now we're looking at endpoint. And actually, before we go to the endpoint, might as well go ahead and calculate the value. So f of 0 will be e to the 0 minus 1, or simply 0. So 0, 0 is one extreme. Okay? And so the critical point is xy equal 0, 0. Now endpoints. Okay? So we're looking at f of negative 5 equals e to the negative 5 minus negative 5. So we're looking at 5 plus 1 over e to the 5th. Okay? E to the 5th is an enormous number, so 1 over e to the 5th is very close to 0. So this is approximated to 5. Okay? And then we look at f of 2. F of 2 will be e to the 2 minus 2. Okay? So it will be negative 2 plus 1 over e squared. So now between these 3 points, so we have the 4 points, we are looking at either 0, 0, or we are looking at negative 5 and 5 plus 1 over e to the 5th, and we are looking at 2 and negative 2 plus 1 over e squared.
0, 1. Professor, why is it 1 over e squared?
No, it's not 1 over e squared. You're right. It's 2, negative 2 plus, so it's that's it. That's the answer right there. E squared minus 2, sorry. Okay. Somebody said something about 0, 1.
It'd be 0, 1 because the original equation is e to the 0 minus
Oh. The original equation is e to the x minus x.
Yeah.
And if x equals 0, e to the 0 minus 0, I see. Okay, I'm getting really, really tired.
But you taught us this stuff, so we know you know.
No, it's not fatigue. It's my neck is just the base of the neck here. It's just you have no idea how bad it is. It's just flat out abusing me right now. And I don't know. I took some painkillers, but they didn't kick in yet, or they kicked in, but they are not effective. Okay, so which one is which? Which is the highest y value? Is it e squared or 5?
E squared minus 2.
E squared minus 2 is greater than 5 plus? I don't think so. E squared, well, maybe. It's a tough competition.
Yeah.
E squared is 7.38. So minus
Huh?
Thank you.
E squared is 7.389.
And minus 2 is 5.389. And 5, so this will be higher. So this will be the absolute maximum. And this will be the absolute minimum.
But then we have to show a test on that.
No, because this is the extreme. This is the absolute. Okay,
And
so
then the negative 5 into the equation. You plug in negative 5 in the original equation, right? Which is e to
right,
x
e to the
minus-
negative 5 minus negative 5. So you have positive 5
Oh.
plus e plus 1 over e to the 5. Now you're getting tired.
Yeah, but I still was right in my shot. So I got a little bit.
It doesn't matter what we do now. Neither it's the matter what we do tomorrow. To be honest with you. All right,
The wording on 40 and 41 is just really.
don't do 40 and 41. I'll skip that. What else?
And I was saying the wording on it is what was. We had a hard time understanding.
Professor,
But we don't need it.
I have a question.
Do go.
Why don't we justify this one when we have to do the other one?
I'm sorry?
Why didn't we have to like do the first derivative test for this, but we had to do it on the other one? Huh?
I just asked. It's because it's.
Yeah, it says then use the test of your choice.
Oh, for the other
For
one?
number 32.
Oh, I didn't even see that, so I didn't do it. Okay, never mind. Thank you.
You probably just skip straight to 50 to save more time.
Yeah, just go to optimization.
Yeah.
Please. Just go to where probably you don't really.
Tell me which problem to go to.
50. 50.
Which one?
We're not there yet.
Wait, what's the? 50.
Honor student, on the quiz, the number 11, the regular class says 10 quick questions. The honors have 11 on quiz number 9. I don't know why I didn't do it with the regular class, but for the last one, it's the antiderivative. You need to remember the antiderivative of the inverse trigonometric functions on number 11. I may change my mind and put it also for the regular student. You really want to do 50? What we want to do, we have a certain length, and we want to create a rectangular picture frame that has the largest area. I don't know if you know that, but if you have any what you call it, a rectangular, for a given length, it will be the square. So the answer will be the square root of 195. That's right away. You can tell that. But the problem is like this. This is, let's say this is the width and this is the length, right? And we know that the perimeter equals 2 times W plus 2 times L, and it's 195. That's given. And if we want to find W and L that maximize the area. Okay, the area is simply WL. So to show that really the maximum area is when you get the square root of 195, you show the following. You say that the perimeter of 195 equals 2, well, that 2W plus 2L, so 2L equals 195 minus 2W, right? And L by itself will be 1/2 of this. Okay? The target function is the area. Area is WL, and it will be W times 195 over 2 minus W. So 195 over 2 W minus W squared. And if you do dA dW, take the derivative, right, it would be 195 over 2 . Did I do something wrong?
Yeah, it's divided by 4.
No, you're supposed to multiply like W. You're supposed to multiply. Why did I put X and Y? It's supposed to be 195 minus 2W over 2, and then you multiply X or W to that. And then you
Did I just do it?
You end up getting like 195W minus 2W squared, and then you take the derivative of that.
The area is W times L.
Can you just use that equation, L equals 195 divided by 2 minus W, to prove that L and W are equal? Because that's what I noticed when I was doing it.
They're going to be equal because the way, yeah, it's equal. Actually, there is nothing wrong with what I do because the ADW will be 195 over 2 minus 2W, right? And it's equal to 0. So W equals 195 divided by 4. Okay? So if that's the case, what is L? L equals 195 divided by 2 minus W, or 195 divided by 2 minus 195 divided by 4. Well, this will be also equals, this is 2 over 4, so it will be also 195 divided by 4. Okay? And what is the area? So it's a square. W equals to L. And it's a square. Each dimension is 195 divided by 4. The only thing that I made a mistake, it's I thought 195 is the area. Okay, if 195 is the area squared, then each one would be the square root. But it's a square. The square maximizes the area for a given perimeter.
So we gotta plug that in and find the dimensions.
But the dimension is 195 divided by 4. Which one do you want me to do next? 64?
I
No,
think
do
you
56. Do 56.
I think you go ahead and
Can I, what? Can I go home now? 50, which one? 56?
You asking for 56?
Guys, for optimization, you need to learn carefully the example I did in class 2. Because I think I have an example in the test and the example in the class. And I told you that this is going to be likely to be in the test and all of that. So I don't think I was full of shit when I told you that.
So make sure we get it right.
How many, can you tell us how many optimization questions to expect on the test? Is it like,
I don't remember, but I think no more than 2. Okay, and I think you have 2 related rate as well. So, and I think you have 2 differential slash linearization. All right, 56. The altitude of a jet H that goes into dive and turn around and then turn upward is given by, so 56. H of is a function of the time equals 12t cubed minus 198 t squared plus 9,500. Okay, what is the altitude jet when it turns up out of the dive? The wording is this, find H minimum.
How do you know that?
Because you read,
altitude turns out?
the altitude in feet of a jet that goes into a dive, then turns upward, is given by this function. Okay, the cubic function, where t is the time in second of the dive and turn. What is the altitude of the jet when it turns up out of the dive? So that would be at the bottom when the turn is made. So that will be the minimum. Okay, and the solution will be the critical number. We're going to do h prime dh dt equals 36t squared minus 198t, and we want it to equal 0. So
Yeah, it'd be 396 feet.
2 times 198.
yeah, so this will be 396. And I think it's good because this is 396 divisible by, divided by 36. So that's cool. So equals 0, factor 36t and get a t minus 1 and minus 11. Right? So one solution, t equals 0, but reject this solution, that's at the beginning, and the other is t equals 11. So the altitude will be h minimum, will be h at 11. I mean, you can check, do second derivative test and see that the h double prime at 11 is positive, but h double prime will be 72t minus 396. So if you plug in 11, I'll do that actually. Okay. It just takes no time to do it. So let's do second derivative test. Okay, so h d2h dt squared equal 72t minus 396, right? And when t equals 11 is 72 times 11 minus 396, and this will be positive, so we have minimum at t equals 11. Okay, and h minimum is equal h at 11, so it will be 12 times 11 cubed minus 198 11 squared plus 9,500, and you calculate it and be happy with the result. Okay, so this is the answer, whatever it is. 1514.
No, 1514. 1514.
Okay, what's next?
64.
The strength of a rectangular wooden beam. I never designed anything that had a wood in it. I designed stuff that had steel beam and steel machinery parts, but never wood. I guess we didn't build
Which section?
any serious stuff with wood in our time, but
Which section is that? What's the section number?
4.7. Now the chair is moving. But not when I sit on it. That's
It's the carpet.
all right. So this is we have the term. It's called is proportional to the width times the square of the depth. So S (64) S is equal to, or let's say it's proportional to W times D squared. What we're going to do, we're going to write S equal K times W times D squared, like so. K will be the proportionality constant. Okay? Let's draw the picture a little bit. Okay. So this is D, this is W, this is the diameter, so what do we call it? We call it L. Okay? So L equals 12 inches. Find D and W that maximize S. Okay? So the trick is to find a relationship between D, W, and L, given L, and we know that by the Pythagorean theorem, L squared equals D squared plus W squared. So from here we get that W squared equals 12 squared, or L squared, minus W squared. Okay, so we're looking at 144 minus W squared. S by itself, as we said, it's K times W times D squared, and we'll substitute D squared with what we found out. So it will be K times W times 144 minus W squared. So we can simplify it. This is the target function. So the target function equals 144K W minus KW cubed. And we take now the derivative, S prime will be 144K minus 3KW squared, right? So what happened is we let it equal 0, and we can now divide everything by 3k. 144k divided by 3k is 48, right?
Yes.
So 40, we can write 3kw squared equals 144k, or w squared equals 48, and w equal the square root of 48. 48 is 16 times 3. So it will be the square root of 16, which is 4 square root of 3 inches. Okay? And L equals 144 minus W squared, or 144 minus 48, which is 96. So the dimension W equal, I'm sorry, not L, but D squared. What do they want us exactly to find?
The dimension of the strongest beam that can cut
So D
12 inches.
equals the square root of 96. Okay, 96 is 16 times 6. Okay, so it will be 4 times square root of 6. Alright, 16 times 6. So W equals 4 square root of 3 inches, and D equals 4 square root of 6 inches. Is this the answer in the back? Probably they want it in the decimal form. Hmm?
6.9 and 9.8.
It's probably, well, 4 times 1.732.
That's right.
Thank you. What's next? What time is it now? 6? Almost 6?
68.
And I started at what, 3:40? Came here 10 minutes late, I think. Because I was doing the quiz. Okay.
We are here at your leisure.
Huh?
We are here at your leisure.
Are you? I think my leisure is running out on me. 68, did you say? It would be good if I didn't have that. Okay, let's not feel bad. 68. We want to evaluate the limit as y goes to 0 plus, and we have natural log of 7y squared plus 14y divided by natural log of y. And of course, we'll use L'Hopital rule, but I like to test the possibilities of L'Hopital, okay? So, and of course, when you look at the limit as y approaches 0 plus of natural log of 7y squared plus 14y over, you have natural log of 0 divided by natural log of 0, so you end up having negative infinity divided by negative infinity. So now we can use L'Hopital, okay? 0 over 0, infinity over infinity.
Any indeterminate form.
Well, yes, if you can write the indeterminate form as 0 over 0, infinity over infinity. Okay? Sometimes you can, sometimes you cannot. But L'Hopital works, the theorem apply to 0 over 0 and infinity over infinity. So just by saying, oh, we have indeterminate form, let's use L'Hopital, that will be wrong. All right, so let's see it. We need to, so now we'll go and we say about L'Hopital. So here's the notation. Please use this notation in the test. L apostrophe H. And now we take the derivative of the numerator. Well, it will be 1 over 7y squared plus 14y, and multiply by the derivative of 7y squared, which is 14y, and the derivative of 14y, which is 14. And the derivative here will be, the derivative of natural log of y is simply 1 over y. And of course, what I forgot to do, and guarantee that you'll do it, so use pencil in the test, is put the limit here. Because it's equal to the limit as y goes to 0 plus. So where we stand here? We need to make sense of the history, and so let's write it as the limit as y goes to 0 plus, and this is dividing by 1 over y is the same as multiplying by y. So we have 14y squared plus 14y on top divided by 7y squared plus 14y. Okay? And what we want to do is we can factor out y squared. I'm sorry? No, we can apply L'Hopital one more time, because it's still going to be 0 over 0. So we'll apply L'Hopital one more time.
But what about factoring out the y?
I'm sorry?
What about factoring out the y and get rid of it?
It's still going to have 14.
Oh, 14 over 14, it's 1.
Yeah, that's the answer.
Yeah, probably you can do that too. Yeah, but you spoiled the party. You can do it, but let's do L'Hopital one more time. You don't have to. You're right. You're right. So it's the limit as y goes to 0 plus, and we have 28y plus 14 divided by 14y plus 14. And now let's do the substitution. So it will be 0 plus 14 divided by 0 plus 14. So it's 1. Okay? But of course, we could have done that. We could have factored out y and in the previous and finish it with only one L'Hopital. But it wasn't too bad. So, what else do you want me to do?
69.
69? Guys, I'm fading out. Make sure to ask me antiderivative questions. Okay? So I'll do 69 and then I'll do antiderivative. All right?
Just do 76.
Well, somebody asked me about 59, and 69 is an Did I have 69 in the homework? I remember seeing that.
No.
Did I do it in the class?
Yeah, you did something with it.
Professor
We
Egan,
asked your question in one of our classes.
which questions are the antiderivative questions?
I'm sorry?
Which questions are the antiderivative questions?
I think,
I asked about that.
did I put it at the bottom?
No, they're not in the packet.
Yeah, 75 is antiderivative.
It was X natural.
Oh, yes.
Okay.
75, 76, 77. Basically from 75 to 78 are all antiderivative questions.
Like, we don't have mean evaluator and mean evaluator. So,
Okay, let's look at this. problem. Let's see if we qualify for L'Hopital. Well, let's see. We have 3 to the power of 0 minus 1 divided by 0 times 5 to the power of 0. So we have 1 minus 1 divided by 1 by 0, 0 over 0. So we can do L'Hopital here.
Make sure you change that 3 with a 5.
I don't know why I wrote 3 here. Okay. So the limit is x approaches 0, and take the derivative of 5 to the x. Well, 5 to the x, the derivative, anybody remember? Natural log of 5 times 5 to the x. The denominator, we need to use product rule. The derivative of x is 1 times 5 to the x plus x times the derivative of 5 to the x, which is natural log of 5, times, let's do it this way, times a 5 to the x. I meant to put it here like so. Okay? Can you see this thing? I don't know, maybe I'm tired, but I don't see it well, so. So what happened here when we have 0? Do we have any problem? I don't think so. We direct substitution here. We have natural log of 5 times 5 to the power of 0. So at the top we have natural log of 5, right? And here we have 5 to the power of 0, so we have 1, and here we have 0. So 1 plus 0, so it's simply natural log of 5. You know, I think I have this question in the test. I don't swear to it, but I remember seeing it in the test.
Yes. Worked for me.
So, okay, let's do one more, and let's. It's not like I don't think I'll have Newton. It's not that I don't know if I have Newton or not, but if I have Newton, it will be 1 or 2 steps. So which one do you want me to do from antiderivative? Choose one, the good one.
78.
78 it is. Okay. R of theta, R prime of theta equals 9 minus cosecant squared of theta, okay? And R of theta is passing through pi over 4 and 0. Okay, and we need to find R of theta. The solution, okay, R of theta equals the antiderivative of R prime of theta. Or we can write it as the integral of 9 minus cosecant squared of theta d theta. Okay, so it's equal to the antiderivative of 9 is 9 theta. And what is the antiderivative of negative cosecant squared? It's the cotangent. is a positive cotangent theta. And what did I not write? Plus C. Okay? And now R of pi over 4 equals 0. So 9 times pi over 4 plus cotangent of pi over 4 plus C equals 0. What is cotangent of pi over 4? It's sine of pi over 4 divided by it's cosine of pi over 4 divided by sine of pi over 4. It's 1. They are equal to each other. Guys, tangent and cotangent of pi over 4 are 1. Don't get me upset so late in the day. So, because I taught many of you the trig, right? At least, well, that one person who took my trig knew the answer. Who else? Who took trig with me? Juan, you should have known that. Wilfred, you should have known that. Andres, you may have known that.
You would tell me to shut up in class because I knew all my identities.
Yeah, okay.
Yeah, sure. I wasn't that class, remember? He was like, what's priorities and then be quiet, you place. I remember perfectly.
We should continue with the review.
So what do we have? We have 9 theta plus cotangent theta minus 1 minus 9 pi over 4. I don't know which question will be in the test, but a question that containing antiderivative with or without a point is guaranteed to be on the test.
Yay. I saw my
Did I tell you there are 12 questions? 12 questions. 12 questions. Starting with 2 multiple choice, and then filling in 1 word, sketch a graph.
We're going bowling, you wanna go, Professor?
We're going bowling. Wanna come?
I'm sorry?
Don't play bowling. We're gonna go bowling, you wanna come?
My dream. I know that I have something that I need to do now. Perhaps I need to print the
You get my
test.
seat.
I need to stop the video.
Might be that I need to actually print the test.
So